Hey everyone, so today we're going to do the remainder theorem. The idea behind this, well, we're connecting it to our factoring, right? Factoring, think of the inverse of multiplication, right? Well, what's the inverse of multiplication? Division. Where have we seen remainder, the word remainder before? Hopefully you're thinking like elementary school, we had a remainder when we divide, okay? Well, and that's the idea. If we're finding factors of anything, we're actually thinking of division. So that's what we're going to get into. Now, this remainder theorem here, this idea allows us to find factors of a polynomial. Okay, this is kind of our trick way of finding actual factors to our polynomial. So right now, what we're going to do is we're going to say a binomial, and we're going to see if it's a factor of our polynomial. Now, a factor means that there's no remainder. The awesome thing about this is if you have the binomial of x minus a, and we plug in a to our polynomial, if it comes out to 0, then we know it is a factor. And if it's any other number, that means it's not a factor and there would be a remainder to it. So today what we're going to do is we're just figuring out if these binomials given to us are factors of the polynomial, okay? So what we need to do, and I'm going to show you tricks because of course there are different setups, right? So the idea here is we want to figure out if x plus 5 is a factor of this 3x squared plus 14x minus 5, okay? So what I want you to think about is what would make your binomial 0, okay? Of course, some of you, this is going to go super fast and everything, but I'm going to take it step by step. So what makes this 0? Well, then I look at it and I'm like, well, that would be x equals -5. So what I'm going to do with that -5 is actually plug it in. So really, I'm saying f of -5, okay? Which we've learned that when we have that, it means we're going to substitute in -5 for all the x's, okay? I'm going to do the order of operations stuff quickly, since I'm assuming you know how to do that, or you can use your calculator, right? Because in your calculator, you're going to go 3 parentheses -5 squared plus 14 parentheses -5 minus 5. And what do you know? When you plug that into the calculator, you get the value of 0. So what that means is x plus 5 is a factor, which also means that in the future, when we do long division or synthetic division, this will go through nicely, okay? All right, B. So in this case, what makes this 0? Well, that would be x equals 3. So we're going to plug in f of 3. And we get 2 times 3 squared minus 7 times 3 minus 4. All right. And if we put that in our calculator, we end up with -7. So no, x minus 3 is not a factor. So if we did long division for this one or synthetic, it would have a remainder at the very end, okay? All right, see here, again, what makes this 0? That would be x equals -2. Maybe pause the video right now, see if you can calculate it on your own to get the right answer. Make sure you understand what we're doing. -3 times -2 minus 6 times -2. Wow, this is a long one, right? Plus 8. And then equals. Well, when that equals, it comes out to 0. So that means, yes, x plus 2 is a factor. Now, this helps because when we get to polynomials, especially that are greater than a quadratic, we can't factor easily, right? So we have to use some division to allow us to break it down. The problem is you don't want to test every number possible, right? And do all this work, and you'll see how much work we're going to do with it and get nowhere with it. So this remainder theorem allows us quickly to identify if a binomial is a factor or not, so we don't have to put all that work into it in the future, okay? Now, this one down here, what's the difference? Wow, my coefficient for x is another number, not just one. So what do? Well, it's the same idea, guys. Set that equal to 0 and solve. So when you solve that, you get x equals 5/2. If you're wondering where that came from, I added 5 to the other side and then divided 2. And then we're going to do the same idea. Oops, 5/2. Okay. And then plug in 5/2 for every x we see. So 5/2 squared minus 5/2 minus 10. And what do you know? When you plug that in the calculator, you get 0. So yes, 2x minus 5 is a factor. Remember, if it's a factor, it means it can be broken up nicely, evenly into that. Okay. All right, let's try some practice on that.